Hello, this is Mr. Henry, and this is lesson 8.3. Last couple lessons we've talked about have been dealing with exponents. That's kind of the entire point of this chapter 8. Well, today we're looking at negative exponents and zero exponents. Zero exponents you're going to see are actually pretty simple. Negative exponents, on the other hand, can be a little bit tricky. So, make sure you have the essential question copied down. It says, how do I use zero and negative exponents? And we're going to try these three get the goofs. So, number one, let's see. Well, what we'd have to do is we'd have to distribute this 2 to the 3 and to the z. Well, 2 times negative 3 is not negative. I'm sorry. Negative 3 times negative 3 is not negative 6. Negative 3 to the second power would actually be a positive 9, and then a z to the second power. By the way, I'd like to mention that I'm writing with a computer mouse, so my handwriting is going to be sloppy. Sorry. Number 2. So, wrong. Number 2, let's see. Well, a to the third to the fifth is a to the 15th, so this part up here is correct. 2 to the fifth, b to the fifth. Let's see, 2 to the fifth. That's 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, which makes me think this is actually correct. I think this problem is correct. I don't see anything wrong with it. Alrighty, then moving on. Number 3, let's see. 5 to the 4th power to the 3rd power. Well, we'd multiply this, not add. So instead of being 5 to the 7th, it should actually be 5 to the 12th power. Not bad. Okay, so get the goof. We got this one word here, reciprocal. This word probably sounds familiar. It is a word that usually deals with fractions. Hint, hint, we'll be talking about fractions today. When you're talking about a reciprocal is when you take a fraction and you turn it upside down. So it's this turning upside down of the number. So for example, the fraction 1/5 here, it says, if you'd flip it upside down, you switch the numerator and denominator, you'd get 5 over 1, which is just 5. Same thing works with like negative 3 over 2, and, well, if you flip it, you could say 3 over negative 2, or negative 3 over 2, or negative out front 3 over 2. These would all technically be reciprocals of that. As long as you have one negative someplace, you're good. Okay? So, what we're going to talk about here is negative. So, first off, negative. When you have something to a negative power, what this really means is we can take this number and almost imagine passing it over a fraction bar. So if I take this, and as I pass the 4 to the negative power over the fraction bar, what happens is the negative changes to a positive. So the answer to this problem is actually a 1 over 4 squared. Okay, I'm going to do that one more time. Maybe I'll just write it out over someplace else. Let's see, we got 4 to the negative 2nd power. We've got a fraction bar. And let's just play pretend because, well, we're not actually pretending. It's there. Technically, this is times 1, right? Because 4 to the negative 2nd power times 1 is still 4 to the negative 2nd power. I'm not changing anything. Now, when we take this 4 to the negative 2nd power, if we want this negative to go to a positive, what we do is we make the reciprocal of just that piece. So the reciprocal of 4 to the negative 2nd power is pass it over the fraction bar, and it becomes a positive. So our answer is 1 over 4 squared, which, if we simplify, gives us 1 over 16. Kind of weird, I know, but it's not too bad once you kind of get the hang of it. Now, when you're talking about 0 power, everything is much simpler. Anything to the 0 power equals 1, always. So negative 9 to the 0 power, this equals 1. If I had negative 3 to the 0 power, 1. If I had 8 to the 0 power, 1. Okay? Give me just a second. I want to check something, see if I have it in my gallery. Nope. Alright, I have it on my school laptop, not my home. Because I actually made a little thing to describe these negative exponents maybe a little bit better, but I don't have it here, so maybe tomorrow. So, I would like you to try these two problems, letters C and D. You're going to try to write both of these with only positive powers. I'll give you about a 15-second head start, and then I'm going to start working through the problem as well. Okay, I'm going to start working through. I'm not going to talk my way through the problems just yet. You keep working, and then I'm going to go through and describe and explain everything after the fact as well. Alright, so here's what I have. For letter C, well, if you have 0 to the negative third power, that's 0 to the negative third. To make this have a positive exponent, you pass it over the fraction bar. So you go from the numerator to the denominator. See? Denominator. But anything divided by 0 is undefined because you can't divide by 0. So letter C, the answer is this is undefined. You cannot do this problem. Letter D, on the other hand, is a little bit trickier. What we have to do is, first off, for those who missed it, I'll go back and I'll re-show the problem. The answer is going to be 5 to the third power, which is 125 for those who care. But the way I did this, let me reverse and get rid of that and that. I started here because I took 1 to the negative third and 5 to the negative third and got that. Now, to make each of these things have a positive exponent, I need to pass them over the magic fraction bar. So if I took and I move my 1 to the negative third over the fraction bar, it becomes a positive 1/3. If I take the 5 to the negative third and pass it over the magic fraction bar, poof, it now becomes a positive 1/3. So when you pass it over the fraction bar, when you change it from the numerator to the denominator, you change the sign of the exponent. So instead of being a negative, it becomes a positive. And then all I did is simplify this because 1 times 1 times 1 is 1. So 5 to the third power over 1 is just 5 to the third power, which again was 125. Okay? So these negative exponent things can kind of be tricksy. They're fun, but they're kind of tricky. So what I have here for you to do is I have a few problems. Instead of having you go back to get a textbook, these are from the textbook, but instead of having you do that, I have the 4 problems up here. Go ahead, give them a try. Again, I'm going to wait about 15-20 seconds, give you guys a head start so you can start copying them down and doing them. And then after about 15 to 20 seconds, I'm going to start working through them without talking. If you get stuck, you can look up and follow along, but try to do as much as you can on your own. And then when I'm done, I'll explain how I got each answer. Alrighty, you may begin. Alright, I'm done. So I started with numbers 1 and 4 because anything to the power of 0 is 1. So that was easy, and that one was easy. Anything to the power of 0 is 1. For numbers 2 and 3, you had this negative exponent. So what I did is I had it up here. So imagine you had 8 to the negative second power. When you pass it over the fraction bar, you move it from the numerator to the denominator, it changed the sign of the exponent. So now this problem is 1 over negative 8 squared, and negative 8 times negative 8 is a positive 64 in the denominator. So 1 over 64. For this number 3, I had this 2 to the negative third power in the denominator like this, and then I moved it from the denominator to the numerator, and it changed the sign of the power. So now it's a positive 3. And then I just simplify this, and 1 times 2 to the third power is just 2 to the third power over 1. And 2 to the third power is 8, because 2 times 2 times 2 is 8. It's not 6, folks. It's 8. Okay? So, negative exponents. When you pass the power over the fraction bar, when you change it from the numerator to the denominator, you change the sign of the exponent. And then for 0 exponents, if it has a power of 0, an exponent of 0, that thing's just equal to 1. Not too bad. Okay? Part 2 says now we can also use those same ideas here with the same stuff we were talking about before, the same lessons we learned in lessons 8.1 and 8.2, we can use those same ideas here. So if I would write this, well, first off, it's written for me. But this piece, I want it with just a positive exponent. We could say, well, this is 7 to the negative third and 7 to the third. Remember, I'm passing this piece, just this piece, over the magic fraction bar into the denominator. And if we do our math here, if we subtract these two, 3 minus negative 3. Oopsie, I forgot to change the sign. There we go. When I pass it over, I didn't change the sign to a negative, or to a positive. Now if we subtract these two, 7 to the third power over 7 to the third power, they're going to cancel out completely, and we just get 1. The other way to think about this same problem, instead of using it as a fraction, remember our addition rules? If the two powers are being multiplied together, you add their exponents. What's 3 plus negative 3? It's 0. So we get 7 to the power of 0, which equals 1. So either way, 1 is our final answer. So you can do it writing it as a fraction and then canceling out, reducing the way we did before, or using your multiplication across, add the exponents, 7 to the 0 power, which is still 1. Okay, letter B. For letter B, let's see. We're going to take 5 to the negative second power to the second power. So, let's see. Well, we multiply those exponents. We're going to get 5 to the negative fourth power. We do not want negative exponents. Those are kind of like having unreduced fractions. We don't want them. We always want to do something with them to simplify them. So if we take this and pass it over the magic fraction bar, there it is, see it? Boom. Now, it's a positive fourth power. And if we simplify this guy, 5 to the fourth power is 625. Get a little sloppy. So this whole thing is actually equal to 1 over 625. Give you a couple seconds to check and make sure everything makes sense there to you. Here we added the exponents, or you pass him over the fraction bar, and he becomes a positive, and then you reduce, you get 1. Here we multiplied our exponents the way we've done before. If you have a power to a power, you multiply. That gave us 5 to the negative fourth. We then took the negative fourth and we passed it over the magic fraction bar, and it became a positive 1/4. And we just did our math, and we get 1 over 5 to the fourth power is 625, because that's 5 times 5 times 5 times 5. 5 times 5 is 25. 5 times 5 is 25. Ooh, not 52, 25. And 25 times 25 is 625. All right. Well, I've done 2. You do 2. Same routine as before. I'll give you guys about a 15-second head start. Okay. So I have finished letters C and D. For letter C, let's see, I took 3 to the negative second power. To make this have a positive exponent, you pass it over the magic fraction bar, and it becomes 3 to the second power up top over 1. And 3 to the second power, 3 times 3 is 9. Voila, we're done. Letter D. Well, this 8 to the negative first power, just this piece needs to pass over the fraction bar. So you pass him over. It looks something like this then, right? We have 8 to the third power and another 8 to the first power down there. And then we simplify that like we've done before. 8 to the third times 8 to the first is 8 to the fourth. And that's some sort of big number that I'm not going to bother to actually evaluate and find the actual answer. Well, my answer key has it here for those who cared. It's actually 1 over, answer key says 4096, 4096, if you cared enough to do it. Okay? But that's how you would do. You pass only the negative pieces over the fraction bar. Then you simplify. Okay, again, instead of digging out your textbooks, there's 5 through 8, 5, 6, 7, 8. Honestly, the best way to get good at these is lots and lots of practice. So if you're sitting there and just waiting for me to do the problems and not trying them for yourself first, you're never going to learn. So go ahead, get started on 5 through 8. All right. So I finished up 5 through 8. Hopefully you have as well. So in number 5, we had something to a negative exponent, so we passed it over the magic fraction bar, put it to the numerator, and we got 4 to the third power, which then I just actually did my math, I evaluated, and I got 64 over 1, which is just 64. Number 6, I took negative 1 times negative 3. A power to a power, you multiply. So there's my negative 1 times negative 3, gives us me a power of positive 3. And 5 to the third power is 125. Number 7 was almost like one of those examples we did before. We have the same base. Because we're multiplied together here, we can add the exponents. 5 plus negative 5 is 0. So this is really just negative 3 to the 0 power, which equals 1. And for number 8, this was a negative second power here. There you go, make it see a little bit better. And so we passed this 6 to the negative 2 over the fraction bar to make it turn to a positive exponent. See, there it is. So we got 6 to the second power from here, 6 to the second power from here. If we add this up, we get 6 to the fourth power. And then I just pulled out my handy calculator, and 6 to the fourth power was 1,296, and we're done. Okay, so now we've learned all the little component parts. We know about adding exponents, we know about multiplying exponents like here. We know how to take these negative exponents and pass them over the fraction bar to make it change to a positive exponent. We know what to do if we get a 0 exponent. So the next few problems you see on your paper look kinda ugly. So what we want to do is we want to be able to simplify this. So we want to take something that's this ugly and make it look a little bit better. And the directions say write the answer using only positive exponents. That's almost like saying reduce your fractions. That's something you always do. You almost never want to have a negative exponent in your problem. There might be a few times if the instructions tell you to, but usually you always want them to be positive. So here we're going to, let's see, well, I've got this 3 on the outside, so I'm going to distribute this 3, kind of distribute the 3, to all my component parts inside. So I'm going to get 7 to the third power times x to the third power times y to the negative 6th power. Now this y to the negative 6th, I'm erasing it, that way I can move it around a little bit. This y to the negative 6th power, we want to be with a positive exponent. So if we take him, and where's my fraction bar? There, he's magic. If we take him and we pass it over the magic fraction bar, poof, now he has a positive exponent. Now it's to the y to the 6th power. And I suppose we could pretty this up a little bit. This 7 to the third power, 7 times 7 times 7 is 343 x to the third over y to the 6th. So I evaluated my 7 to the third. I guess we're going to start doing that more and more, because before I kind of said leave it with, sometimes I said leave it with exponents. I guess if the number fits in the calculator, just do it. So multiply. 7 to the third power is 343. X to the third stays the same, and y to the 6th down in the denominator. By the way, this x to the third and this y to the 6th do not cancel out because they do not have the same base. One is x, one is y. For them to cancel out, they have to have the same base. Okay, let's check letter B. Ooh, doesn't he look pretty? Alright, one piece at a time. Let's start working on the top first, then we'll work on the bottom, and then we'll simplify from there. So u and u get 5 to the negative 2nd power, x to the negative 2nd power, y to the 6th. we are eventually going to have to take these two pieces and move them down the bottom. We've got nothing down here that I see can be simplified just yet. So I'm just going to write it, x to the third, y squared. Now, we want these two pieces, the 5 to the negative second, x to the negative second, to have positive exponents. So if I pass them over the fraction bar, poof, they now have positive exponents. Now let's see what kind of simplifying we can do. Well, I've got 6y's up top and 2y's down below. I can cancel these out. 2 of you, gone. 2 of you, gone. Alright, so that gives me y to the fourth up top. And then we've just got a bunch of junk down here to simplify. Let's see. 5 squared is 25. So I can take a 25 from here and a negative 4 from there and multiply to get me a negative 100 down below here. And then if I combine my x's, I've got x to the third and x to the second gives me x to the fifth over y to the fourth. Ugly problem. Give a couple seconds, look at it. I'm going to talk through it one more time, just for those who did not quite follow along. So, we started by getting rid of this negative 2 on the outside. We kind of distributed to get rid of these parentheses. Kind of like order of operations. You got to get rid of those parentheses. So we got rid of them. Boom, they're gone. And we had, if I move it back up top here for a second, we had this to the negative second power and x to the negative second power. Ignore that. Then, to get positive exponents, we take those two pieces, we pass them over the fraction bar, and that made it so we had positive exponents. 5 to the positive second power, x to the positive second power. Then all I did is, well, I simplified my y's. I had 2 y's down below and 6 y's above, so I canceled and reduced, and I got y to the fourth up top. And then for my number parts, 5 to the second power is equal to 25, because 5 times 5. And I just took 25 times negative 4 was a negative 100. And then x to the third times x to the second gave me x to the fifth. And this would then be done. All right. Out of the next 3 problems for you to try, only one of them, actually none of them are quite as difficult as this. This is probably the most difficult problem on the page. So if you're not quite understanding, don't feel disheartened. I believe you should still be able to do this. So give these next 3 problems a try, and we'll go from there. Okay, so we've got C, D, and E. Letter C. I've got p to the fifth power. So, I'm sorry, negative fifth power. So to make it a positive, I pass it over the fraction bar. Yeah, I can talk. So we pass it over the fraction bar, we get 1 over p to the fifth. Done. Can't do anything else. Letter D. This problem is only tricky for the folks who think that this 7 is also to the negative third power. It's not. The t is to a negative third power. The 7 technically has a power of 1. So when I'm passing stuff over the fraction bar to make this negative third power a positive third, I am not taking the 7. I'm only taking the t. So the t to the negative third power passes over the fraction bar, becomes t to the positive third. The 7, it had a positive exponent. It stays down there. That would be the final answer. And then down here, letter E, I said don't overthink this. It looks really complicated until you realize this entire thing is to the power of 0, which means anything to the power of 0 is 1. So we kind of fooled you a little bit, or tried to fool you a little bit. Okay? I'm going to give you one more problem to try, and then I'll give you guys your assignment. So don't worry about number 10 right now. Do number 9. So number 9 says simplify this expression. This is, again, from the textbook, but I wrote it out here for you. So you want to simplify it and write your answer using only positive exponents. All right. So I have the whole problem copied here down. The first thing I see is when I look at this, I see I have some numbers that I can simplify eventually. This 9 and this 3 can be reduced. I see I have x's that can be reduced. And I see that I have a y with a negative third power. So the first thing I'm going to do is I'm going to get rid of this negative third power. So I'm going to take this piece, and I'm going to pass it over the magic fraction bar, and poof, it now has a positive exponent. That 4 is a little big. There we go. Now, let's do some of the simplifying stuff. So 3 over 9 simplifies to 1 over 3. Okie dokie. This is x to the first power. This is x to the third power. So if we subtract them, one of these cancels. That's all of them up top. And one of these cancels gives me x to the second power. Down below, I've got y to the fourth times y to the third, giving me y to the seventh power. So our final answer is 1 over 3x squared y to the seventh power. All right. Now, why don't you quickly summary box? This is a little bit on what we have learned so far. A non-zero number raised to the power of 0 is always 1. So anything to the power of 0 is 1. And a power with a negative exponent is the reciprocal of the power. This is when you're passing it over the fraction bar. You move it from the numerator to the denominator. And then you change the sign of the exponent. Okay. So, homework. These problems you should see are fairly quick, so don't be freaked out by the numbers. So what do we have here? We're going to modify this slightly. It says page 506, so you actually need to get a textbook. Depending on how much time is left in class, you can get a textbook and get it started now. Page 506, numbers 3 through 45, multiples of 3, and I'm going to take out these last two problems. These are the word problems that we actually skipped on the note sheet. You probably noticed we skipped a couple of the word problems. Okay, so do page 506, 3 through 45, and I will check it tomorrow, answer any questions we have, and go from there. Thank you for your attention, and have a nice day.